The floor quivers for a split second, and just like that, Earth slips us a note. It's written in a language older than any alphabet, vibrations that sprint through rock, metal, and time. For most of history, we couldn't even open the envelope. Today, we chase those ripples across hemispheres, turning them into the planet's private X-ray. What they've shown us beats any sci-fi set piece: an ocean of liquid iron and a heart of solid metal hotter than the sun's lawn. Here's the crash course. When rocks snap along a fault, they fling out energy. Some waves compress like a slinky shoved down a hallway. Those are P waves. Others wiggle side to side like a rope you've given a sharp snap. Those are S waves. P waves will happily squeeze through solid, liquid, or gas, but S waves throw a tantrum at liquids and refuse to move. Plant seismometers all over the globe wait for a decent quake, and you'll notice something spooky. There's a huge patch on the far side where S waves never check in. It's the ultimate no-show. That silent zone was our first postcard from the molten layer below. Early 1900s researchers mapped quake arrivals and spotted a donut-shaped gap between 104 and 140 degrees from any epicenter. They dubbed it the S-wave shadow zone. Imagine standing in Los Angeles while Tokyo shudders, yet your friend in Denver feels nothing, even though Denver's closer. The only explanation: somewhere en route, the waves hit liquid metal and S-waves slammed into a cosmic road closed sign. That liquid shell is the outer core, a mercury-thick alloy of iron and nickel starting 2,900 kilometers down, wide enough to swallow Mars. We've never laid eyes on it, yet we know its address, size, and mood swings. P waves don't vanish, they just lose the hurry-up. Picture sticking a straw into a glass of water at an angle. Light bends, and so do the waves. When P waves smack the outer core, they slow, refract, and pop out late. Measure the delay and you can weigh the core's density in your head. 1.3 million atmospheres at the top, 3.3 million at the bottom. Temperature? North of 5,000 degrees Celsius, hotter than the photosphere of the sun. Still a liquid, because pressure shoves the melting point sky high. It's a planetary tug-of-war. Heat wants to freeze it, pressure wants to melt it, and the compromise is a planet-wide swirl of metallic ocean thicker than the moon is wide. P waves that survive the outer core suddenly speed up again at the very center. That told scientists something even denser waits below. The inner core, a Pluto-sized sphere of solid iron nickel. Temperatures crest 6,000 degrees Celsius, yet the metal is solid because pressure squeezes atoms into a crystal lattice harder than diamond. The boundary between liquid outer core and solid inner core is knife-sharp. One side flows, the other stands like a monument. Every quake pings that border like sonar off a submarine, letting us measure the inner core's radius within a few kilometers. No drilling required. Stack the layers and Earth becomes a cosmic onion. The crust we fret about is the papery skin, 5 to 70 kilometers thick. A 747 at cruise altitude is already a fifth of the way to the base. Underneath sits the mantle, 2,900 kilometers of magnesium iron silicates. It's technically solid, but over geologic time it oozes like refrigerated honey. Convection here drags plates the way conveyor belts shuffle luggage. When oceanic slabs sink, they leave breadcrumb trails of deep earthquakes hundreds of kilometers down. Each tremor is a hiccup in Earth's recycling program. Old crust dives, melts, and eventually burps back up at mid-ocean ridges. That swirling outer core? It's Earth's generator. Molten iron rises, sheds heat, sinks, and spawns electric currents that knit the magnetic field. Without it, cosmic radiation would barbecue our satellites and peel the atmosphere like an orange. The field drifts westward a few centimeters each year and occasionally flips poles. Volcanic rocks and seafloor basalt tape record these flips, giving us a billion-year diary of core shenanigans. Every quake gives the dynamo a gentle knock. The returning waves report how fast the core is stirring and whether our planetary force field needs a tune-up. No white coat? No problem. Lay your phone flat, open a free seismometer app, and the same chip that flips your screen now moonlights as a quake detector. Anything above about magnitude 5 within a few thousand kilometers will show up. When the Philippines shook at magnitude 7.1 in 2021, hobbyists in Perth saw P waves roll across their kitchen tables. Multiply that by thousands of citizen sensors, and the gaps between professional stations shrink. Charge your phone overnight, and you might add one more pixel to the planet's living X-ray. This isn't just geek trivia, it's survival intel. Knowing where the mantle drags plates tells us which faults are cocked and loaded. Mapping subducted slabs forecasts where deep quakes will strike, like the 2018 magnitude 7.5 Papua New Guinea rupture that rattled a gas pipeline 80 kilometers down. And tracking the outer core hints when the magnetic field might swoon again. Last major dip in the 1800s had telegraph wires sparking with phantom currents. Today, the same drop could fry satellites and brown out continents. Every quake is a free checkup. The copay is measured in curiosity. Want more backstage passes to the ordinary world? Hit subscribe and ring the bell. Tell me the strangest thing you've ever felt underfoot. Quake, subway, or Jurassic Park level footstep, and it might star in the next story. Share this with anyone who thinks science is snooze button material. Let's prove them deliciously wrong. So next time the ground jitters, whether it's a faint magnitude 2 shimmy that ripples your coffee, or a magnitude 7 hammer throw that sets off car alarms, remember, Earth is talking. The waves sprinting through rock and metal are a telegram written in physics, delivered in minutes, readable by anyone who knows the code. Follow them downward, and you'll tour drifting continents, sinking plates, honey-slow mantle, a liquid metal ocean, and finally, a solid iron heart glowing with the heat of Earth's birth. Every quake is a reminder we live on a restless, breathing, churning world, an X-ray waiting to be taken. And now that we can read the message, we'll never look at a shaking floor the same way again.